This is the point of equilibrium, the middle point. So if this is my point of equilibrium, I extend from the point of equilibrium, and you will see that the maximum velocity will be in the middle, which will be equal, EI is equally final if there is no friction, to 1/2 K at the maximum extension. What will be? A squared. This is the way that you use EI is equally final in the block spring system. So we know the energy of the block spring system. We go to the next topic. So I just want to teach the theory. When I bring the study guides, we go over that. What will be the motion? The motion of the block spring system. Imagine that we put this here. At the same time that this, imagine that I paint this with graphite or paint. At the same time that this is moving vertically, I move a paper, or I roll the paper like this. What will be the type of motion, or the type, what will be the graph that this will graph here? So if when this is moving, I move this like this. At the same time that this is moving, and this paint will be what type of function?
Parabolic or quadratic?
Sinusoidal function, right?
Yeah.
So imagine that I have this here. Okay? Here. And at the same time that this is moving, I roll paper like this. So the graph will be like this, which will be a sinusoidal function. So if you have this here, and this is moving back and forth, and you roll a paper like this, at the same that this is moving, it will give a graph like this. If you start recording the motion at the top point, if you start recording the motion at the top point, this will be the point of equilibrium. This is the amplitude. This is negative the amplitude. And it will be like this. This is what type of function? Sine or cosine?
Well, that's cosine, right?
That's cosine. So the function will be, the way that x changes with the time will be a cosine omega, where omega is theta. Omega, we know that is theta times t. From rotational motion, we know that omega is delta theta over delta t. So if we put this, we can say that theta is omega t. So instead of theta, we put omega t plus the phase. What is the phase constant? It's just how much in angular value will be this shifted from here, so from the original value of A, so from the highest point. So sometimes instead of starting here, it can start here. Then you start recording, not necessarily at the highest point, you can start recording here. So how much is shifted with respect to this one? This is this theta value, which is called phase constant. Here we won't use the phase constant. You will use it in electricity though. So we will start assuming that always we'll start recording either from the top point, when it's maximum extended, and the function, this will be 0, so will be a cosine omega t. When we start at t equals 0, the motion starts at x equals a. So you will start recording at x at time equals 0, here, you will start recording the motion from the maximum extension, no phase constant. But if you start recording at this point, can be either this way or this way, which will be a sinusoidal function. Will be a x equal a sine omega t when t is 0 and x is at the point of equilibrium. So if you start recording the motion at the point of equilibrium, again, no phase constant, but will be different with respect to this graph by 90 degrees. And the difference between sine and cosine is by 90 degrees. So which will be this. But if we start recording from A, maximum amplitude will be a cosinusoidal function. Now, what will be the velocity? In order to find the velocity, what we need to do? What is velocity by definition? That's average velocity. The instantaneous, the derivative of the position. If this gives you the position function at any time, where omega is called the angular frequency or angular speed, t is the time, a is the amplitude, x is the position, the extension or compression at any time. Remember that the cosine goes from -1 to 1. So it goes from here to here. So if you multiply -1 to 1 times 8, let's say when the time is 0, what will be cosine of 0? 1. 1 times 8. So at 0 times, we are at this point. At any other time, have to be less x, which is x will be less changing because the time. Cosine goes from -1 to 1. So this always goes from -8 to 8. Now, if I want to get the velocity, what do I need to do? To this function, to the x function, I get the derivative. That will be the velocity. So if you get the derivative to this, what will be? To this one, sorry, starting with A. A sine, but it's sine or negative sine? Negative sine, A negative sine, and then you have to do the chain rule. Omega is a constant, what will be? A omega times what? Sine omega t. This will be the velocity. But remember, it can be negative or can be positive because these go back and forth, back and forth. So what will be the acceleration? Now, what will be the maximum velocity? Maximum velocity. The sign always goes absolute value. I am talking about absolute value. What will be the maximum velocity? When the sign is maximum? Or 1, when it's 1, right? Go from -1 to 1. If we give the magnitude, go from 0 to 1. So what will be the maximum value then for the velocity? Absolute value? A omega. So omega A. This will be the maximum velocity. If we want to get the acceleration from the motion, we know the acceleration already. What is the acceleration? Here we have